The second unit of RFID and flexible sensors. Here it deals the RFID tags and protocols. So in RFID, just refer to the core functions an RFID tag can perform. So these capabilities vary depending on whether the tag is passive or active or semi-passive. So basic tags store only an ID number, while advanced ones can hold the product details or history or sensor data. So tags can communicate with RFID readers using radio frequency signals. They are support read and in many cases writing also it is supported, which means updating their data. Next thing is security features. It's in just a basic level because simple tags may support password protections or kill commands to permanently deactivate that tag. So higher end tags can be include encryption and then authentications also. Suppose we want to sensing some tags means it just a certain RFID tags, it includes the sensors like temperature, humidity or motion. It can to monitor the conditions. Then comes to when communication range is very important because it's a capability to operate at a different ranges. It's depending on the frequency levels only. It also having three levels of frequencies. That means we know low frequency, it just like a few centimeter only. Then comes to an high frequency up to 1 meter, and ultra high frequency it just covers some several meters. So active tags up to 100 meter or more. So the basic tag capabilities of RFID are identifying the objects, storing and exchanging the data, supporting read-write operations, and sometimes providing security and sensing features. So next one, it shows the typical RFID tags, right? It includes passive tags, active tags, and then semi-passive. The semi-passive in the sense it is a battery assisted passive. So passive tags, it has no internal battery. It just powered by reader's signal only, which means it looks like thin and lightweight and then inexpensive also, and it covers the short ranges. A few centimeter to 10 meters. It depends on the frequency level. Its common usages is retail inventory as escorts, supply chain trackings also. Then comes to an active tags, heavier than one battery to power transmission, which means it covers longer ranges. So it's commonly used in vehicle tracking, toll collections, asset monitoring also. Then comes to a semi-passive, it's a battery powered. Battery power internal circuits, but communication relies on the reader's signal and better sensitivity, and it's ranger than passive but cheaper than active. So common uses of semi-passive is cold chain monitoring with the sensors and logistics also. Based on data capability, read only tags and write once, read many, and both read and write tags. It can be updated multiple times also. So these are the typical values of RFID tag. So in comes to an antenna design, it determines the operating frequency and read range, and it made it from copper, aluminum or silver links also. Then comes to a chip, that is an IC, that is integrated circuits. It's very small. It stores unique ID and then data. It connected to antenna to enable the communication. It looks also some other glass for implants on animals, and it looks like a metal for industry applications. And comes to when durability, it's one of the physical characteristic, that is some tags are disposable like retail labels. Then comes to when mounting options, adhesive backing is possible, that it looks like a stickers, and screw or bolt the mount for hot tags, and embedded or implanted glass tags is possible. Then it comes to when tie on or clip on for assets is possible in mounting options. So these are all the physical characteristics of RFID tags. The most important topic in RFID is air interface. So the air interface is an RFID. It refers to the wireless communication channel between an RFID reader and then RFID tag. So it defines the some set of rules with a frequency and protocols that govern how readers and tags exchange the data using radio waves. So the air interface is essentially the language that allows an RFID reader and tag to communicate. So it covers power transfer, modulation method, data encoding and anti-collision techniques, right? So the function of the air interface, it includes the power transfer, communication, identification and then data exchange. So the frequency band used in air interface, it deals low frequency, ultra high frequency and then high frequency and microwave, right? So modulation and then coding. So that technique just carry the data on radio waves using some coding techniques like amplitude shift keying and then phase shift keying, like that. Then comes to encoding, sometimes for example we are using Manchester coding. It just used for organizing the bits for transformation. Then comes to protocol standards. It stand like ISO and then EPC global class 1 generation 2. That means it covers ultra high frequency. So these ensure interoperability between the different readers and then tags. Then comes to anti-collision mechanisms. When multiple tags respond at same time, the reader must separate signals like aloha and tree based protocols. So importance of air interface, it just ensure reliable communication and it allows multiple tags and it provides efficient data transfer based on low frequency, high frequency and ultra high frequency. It's fully vary depends on their applications. So these are all the frequency levels described in each frequency module. The air interface in RFID is the backbone of RFID communication. So it defines the rules of powering, identifying and exchanging data between the tags and readers. With its standards like ISO and then EPC Gen 2, the air interface enable RFID to be used globally across the industries for automation, inventory control and then tracking. First one is amplitude shift keying, which means it haven't strengthened in carrier wave. It just varied according to the digital data, which means that application having high amplitude, which means it shows as 1. Suppose it having low amplitude means it shows as 0. Okay, so it's used in LF, which means low frequency, high frequency. Comes to when frequency shift keying, the frequency of the carrier waves is changed to the represent the bits. Like 1 means one frequency and 0 means another frequency. So it's used in some LF animal stacks, older RFID systems. So it's more noise resistant than amplitude shift keying. Then comes to phase shift keying, the phase of the carrier signal is shifted to represent the digital data. So it's a common variance. It includes the binary PPSK and then quadrature PSK, which means binary in the sense it covers 180-degree phase shift for zeros and ones. Then comes to quadrature PSK, it covers 90-degree phase. So it's used in advanced RFID and then UHF tags. It's more efficient and require complex receivers. The next important topic in RFID is coupling. Tag can be used directly affect the read range between the tag and reader. right? It may be it's close or remote and long ranges also. So the types of coupling in RFID, the first one is backscatter, and second one is inductive, and third one is magnetic, and final one is capacitive. So I will explain one by one. The first and foremost thing is a backscatter coupling. So backscatter coupling is a far field communication method where an RFID tag reflects or scatters the electromagnetic waves sent by the reader back to it after modulating the signal to carry data. So it is the key principle used in ultra high frequency and microwave RFID. Backscatter coupling is far field RFID communication technique where the tag reflects and modulates the reader's RF signals back. It just enable a long range, fast and bulk identification in ultra high frequency and microwave RFID systems. Magnetic coupling in RFID is the transfer of energy and then data between a reader and tag using a magnetic field. So it is the foundation of inductive coupling, making it deal for short range, secure applications like access cards and then smart tickets. So the final one is capacitive coupling. It just uses an electric field like a capacitor. It just to transfer the energy and data between a tag and reader over the very short range. So it is mainly found in contactless smart cards and then e-passports. So this slide shows the RFID information storage and processing capacity. So here the RFID tag differs in how much data they can be stored, and some are designed only for simple signaling. So here is a clear explanation of the types of U needed. And the first one is 1-bit EAS tags, and second one is surface acoustic wave, that's SA tags, state machines, and then microprocessor.